How do you go about interpreting your DOE response? How do you go about interpreting your equation? On one hand, I think it's pretty straightforward. On the other hand, I've had a lot of experience with it, so it's maybe more obvious to me than a person first to it. But let me give you a few principles, and I think it'll help you out. First off, I think people become overwhelmed by the idea just because they look at, maybe they're a mechanical engineer looking at a chemistry example, or they're a thermal analysis person looking at a mechanism example. If it's not your area or something that you deal with on a repeated basis, it's not going to be maybe so obvious to you. But if it's in your area of expertise, I think the interpretation becomes much easier. And again, it's maybe balanced off of some of the principles I'm going to share with you. But they talk about there being 4 different types of variables, and how do you set those variables for a given output. One of those variables is a variable that impacts nothing. It doesn't impact the mean or standard deviation of your system. If you have one of those, you can set it to a low cost or use some of the other criteria you may have beyond the numerical answers with the equation. There's another type of variable that can impact only a standard deviation. If that's the case, set it at a level, assuming costs are practical, at the area that's going to reduce your standard deviation, give you more consistent, more capable output. There's others that only affect the mean. So you can use those to tune at the very end of your optimization process. Modify the mean to hit your target value, that desired location that you want to operate. And of course there's some that impact both standard deviation and the mean, so you need to balance those with the other ones that we've already talked about. But understanding the types of variables and based on the graphs that you have, output graphs, or if you understand the idea of the graphs, looking at the equation, that can help you decide how to best interpret and best select the ideal settings for your case. However, this is all dependent upon your confidence in the equations. If your statistical analysis comes out really pure and perfect, then it's easy to do that. If they're a little bit dicey or a little bit marginal on some of the statistics, then you have to be careful in how you apply it and what your follow-up testing may be. Either doing verification tests or at least being a little bit cautious in selling those solutions and who you sell them to. Also, the things that I think of when I walk through it, you may have 5 variables in your equation, but what were the maybe 2 or 3 that were most important? And if you have more than one response, that's the other thing. How do those multiple responses prioritize to each other? If you have the same 2 or 3 key factors for all of your different responses, then it becomes an easy thing to interpret. But if these 2 or 3 are important for response A, and another 2 or 3 with some overlap for the second response, how do you balance those out? How do you find that sweet spot? And it's different than pure optimization. It's understanding and seeing those trends when you look at the data. And then obviously, not everything can be measured. Not everything's included in your DOE. There's oftentimes, I'll call intangibles, that come into play. Maybe there's an implied cost. Maybe there's an implied throughput time. Maybe there's an operator safety aspect that you need to consider when you make those final selections. It may be less of a numerical optimum, but it may balance some of the other considerations in a more safe way that maybe you haven't put a numerical factor to, but you know the impact that it's going to have, and you can assess the cost-benefit trade-off. So those are things that I look at when I'm interpreting. There is a little bit of an art to it, there is a little bit of science to it, but I think anything that's in your work area, with the tools and the information and understanding that DOE gives you, with a little bit of guidance, I think you can become pretty proficient at it. I seem to have an ability to see things that other people don't see, but for the most part, 80% of your problems you're going to be able to solve with basic graphs and basic equations using the principles I just shared. Hopefully you find this useful. You can interpret your own DOEs and make your decisions, move your company forward. If you need some assistance with it, give us a call here at Perry Solutions or email us through our website. We'd be happy to work with you, see what we can do about moving your product or process forward.